Hey everybody, welcome back. Welcome to Chapter 4. Chapter 4, we're going to start out with exponents today. We're going to get going and we're going to be finding the product. So the very first thing I want you to do is do these 4 warm-ups, and I want you to make sure you know how to do them. Take 5 times 5 times 5 times 5 and 3 times 3, so on and so forth. Answer them and we'll look over the answers. So pause and try them out. Okay, very first one, we have 5 times 5 times 5. When I multiply the first two, 5 times 5, I get 25. I'm still left with 5 times 5. 25 times 5 times 5. Multiplied 25 times 5, I get 125. Then multiplied times 5 one more time. My answer is 625. 625. Next one. 3 times 3 times 3. When you take 3 times 3, you get 9. Then multiply 9 times 3, you will get 27. Next one. Negative 7 times negative 7 times negative 7. Notice on this negative 7 times negative 7 times negative 7, you're not only multiplying 7 times 7 times 7, but also negative times negative times negative. So when you do that, you get a negative 7 times negative 7 is positive 49. But then you have to take that and multiply by a negative 7 one more time. Your answer is 343, but it's negative. Don't forget about the negative. Okay, negative 343. All right. Last but not least, number 4, I think maybe have been the easiest of the bunch. 9 times 9, 81. 81 is your answer. So you get 625, 27, negative 343, and 81. All right. So when you look at this today, we're going to be learning about how to evaluate expressions, but not just any expressions. We're evaluating expressions with exponents. So you may have had a little bit of preview work into this, but we're really going to dive into it. Let's go. Exponential form. Exponent, base, power. Now, when you look at exponential form and exponent, those are the definitions. I want you to pause now, write it down, and then I will explain. So when you look at exponential form, when a number is written with a base and an exponent, that W it just means whenever a W is over a letter, it's with a base and an exponent. So when a number is written with a base and an exponent. For instance, if I give you 3 to the 27th power, 3 in 27th power, that is an exponential form. That's going to be a huge number, but it is an exponential form. The exponent, that tells you how many times the base is used as a factor. So if you go back up to this 27 is my exponent, okay? And what happens is you are figuring out how many times you're multiplying that 3 by. Okay, so if you look at that, 3 to the 27th power, you would get 3 times 3 times 3 times 3 times 3 times 3 times 3. I can stop because I don't want to do that 27 times. You would multiply that 27 times, not 3 times 27. You would take 3 times 3 times 3, 27 times. Next, we have our base. We have a power. So I want you to pause, write these down. Okay, so when you look at a base in a power, that is the number used as the factor. So if I go back to 3 to the 27th power, okay, 3 is my base. Now, whatever that answer is, okay, whatever that answer is known as a power. Okay, that number is a power of 3. That is the number produced by raising a base to an exponent. Also write this down. This gives you a good hint right underneath that power and base. So please pause now. Write that down. All right. So what this means is 2 to the 7th exponent. You will get 2 times 2 times 2 times 2 times 2 times 2 times 2. You will get your power. Okay, so once you multiply all of these together, you will get your answer. Okay, so when you look at that, your answer would be 128 because I multiplied 2 to the 7th power. 128 is a power of 2. Now, the one thing I want you to notice, because I do see this a lot, you do not take 2 times 7. Do not do that because 2 times 7 is 14. 14 is a lot different than 128. Okay, so do not take your base times your exponent. That's a common mistake. Take your base and multiply that base 7 times, or multiply it as many times as you have as your exponent. Okie dokie, artichoke. So, please write this down. I will show this first one, and then I think you can write the next two. So pause to write it down. All right, so when you look at this, you're writing in exponential form. Exponential form, meaning you're going to get a base to an exponent. So it says 4 times 4 times 4 times 4. The very first thing is, what is my base? My base is the number I'm multiplying by, which means my base is 4. My exponent is the number of times I'm multiplying 4. So I'm multiplying it once, twice, 3, 4 times. My exponent is 4. However many times you have that your base multiplying, that is what your exponent is. I want you to pause now and try these next two. All right, so now we have negative 6 times negative 6 times negative 6. What is my base? Negative 6. Okay, what is my exponent? Well, how many negative 6's do I have? I have 1, 2, 3. Now, this is a little bit tricky, okay? Because my base is negative 6, on any negative numbers, I need to use parentheses, okay, with my exponent of 3. And the reason behind that is, if I give you a negative 6 to the 3rd power, that's like saying negative 6 times 6 times 6. Instead of, on this very first example, negative 6 times negative 6 times negative 6. Okay, those parentheses mean everything. Okay, without the parentheses, I am just taking the negative answer of 6 to the 3rd power. It almost looks like this. You can even try this in your calculator. Without your parentheses, okay, it will take the negative answer of 6 to the 3rd power. With parentheses, it will take negative 6 to the 3rd power. They are different. You will actually get the same answer with this. However, if you look on your calculator and you try it on your calculator, you want to do it by yourself, I want you to take negative 4 in parentheses on your calculator to the 4th power and negative 4 to the 4th power. You will get two different answers if you want to try it. Okay, next one. If you look at this, we have 5 times 5 times d times d times d times d. When we do this problem, we actually have two different bases. What are my bases? I have 5 and I have d. Okay, still multiplying in between them. Exponential forms state, what's 5 times 5 in exponential form? 5 to the 2nd power. D times d times d times d in exponential form? D to the 4th. That is my answer. Okay, because I don't take 5d to the 6th because I do not have 6 d's. Notice I have 4 d's. Same thing. I do not just have 1 5, I have 2 5s. So watch out for those in exponential form. You need to make sure that you put your base here with the number of times we multiplied. We multiplied 5 2 times. Same thing on the other side. I multiplied d 1, 2, 3, 4. Those need to go with d, and I'm multiplying in between them. Okie dokie? Awesome. Next. So now I have to evaluate. 3 to the 5th power, negative 3 to the 5th power, and 2 to the 8th power. So I want you to pause now and write these down. All right, 3 to the 5th power. What in the world does that mean? Does that mean? It means 3 times 3 times 3 times 3 times 3. Okay? You are multiplying 3 times 3 times 3 times 3, multiplying 3 by itself 5 times. Cinco, 5. 5 times. Not 3 times 5. You are taking 3 times 3 times 3 times 3 times 3. Are you sick of me saying 3? Well, guess what? There's another one next. Okay, when you multiply straight across, getting all of those 3, that is 243. 243. Next one. Negative 3 to the 5th power. What does that mean? That means negative 3 times negative 3 times negative 3 times negative 3 times negative 3. And there we go. I almost added another one. Don't forget, we also have these parentheses. That's what it means. So when you take negative 3 to the 5th power, what's my answer? A negative 243. Negativo 243. Okay, it's negative. Now, 2 to the 8th, this is a little bit more. What does 2 to the 8th mean? It means 2 times 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 2. I almost forgot one. I had to count there at the end. Okay, so 8 times. And when you take 2 times 2 times 2 times 2 times 2 times 2 times 2, okay, what is your answer going to be? 256. 256. My answer, 256. You may be wondering, Mr. Sheeman, Mr. Sheeman, Mr. Sheeman, do we get a calculator? Oh, my dear students, no. I know this is a lot of multiplication, and I know that. I will not give you a very large base with a high exponent on your quiz or on your test. Okay, so you're not going to get a calculator on this chapter, but do know that my bases and my exponents will not be like to the 14th power, to the 12th power, or to the 9th power. Okay, unless it is something like 2 or 3. Okay, all right, next. All right, now we have to evaluate a negative 5 to the 2nd power. Try to see this one. Pause now, try it. All right, this one is a little bit tricky because notice what is the meaning behind this? I would take the negative answer of 5 times 5. Okay, remember that negative sign, if you notice that is not in the parentheses. This right here is a lot different than this. Okay, do you notice how inside the parentheses we include that negative 5 there? That negative sign. However, up here on this first example, this first one, we do not include that negative sign. So my answer, I take the negative answer of 25. My answer overall is a negative 25. Be careful because those do get tricky. Watch and see where my negative sign is. If it's in parentheses, you include it when you multiply straight out. If it is not in parentheses, you cannot include it. All right? Okay. All right, so now we have to evaluate x times y to the x minus z to the y plus x to the y. Whew, boy, there's a lot of variables here. But it also gives me my variables down here. X is 4, y is 2, z is 3. Think about what is the very first thing you have to do. What is the very first thing you have to do? Substitute. You need to substitute those wonderful numbers in for those variables. So plug in those variables Then use order of operations and solve. Don't forget about order of operations. You can't. The rules of math are order of operations. Okay. Now, I want you to pause now. Try this problem. All right. So now let's check to see what you got. So plugging in numbers. So if x is 4, my overall problem would be 4 times 2 to the 4th minus 3 to the 2nd plus 4 to the 2nd. It gets confusing, but wherever you see an x, plug in, notice I plugged in a 4. Okay? Wherever I saw a y, I plugged in 2 here. And wherever I saw a z, I plugged in a 3. Okay? So now all it comes down to is order of operations. So what do I have to do first? Well, technically parentheses. However, I cannot evaluate parentheses without my exponents. Okay? So I need to do 4 times, what is 2 times 2 times 2 times 2? 16 minus 9 plus 4 times 4, 16. Notice how I simplify there first. Now I get the grand pleasure of coming up with my answer. 16 minus 9 is 7. That's how I came up with 7. Plus 16. Now what do I have to do? 4 times 7. 4 times 7. 28. Plus 16. Add 28 and 16. 44. My answer, 44. Notice, I started with plugging my things in. That's step 1. Step 2, you start evaluating your problem. Okay, your second step is get rid of those exponents. Then I went through the order of operations with step 2 is also order of operations. All of these are order of operations. You need to solve there. Okay, last note of the day. It says use the formula 1/2 times n to the second minus 3n to figure the number of diagonals in a 4-sided figure. Okay, so what you have to do, n stands for the number of sides. N is the number of sides. So 4-sided figure, think about what our n is, plug that in and solve. So pause right now, plug everything in and solve. Go! All right, so if my n is my number of sides, n is equal to 4. Why? 4-sided figure right here. It says 4-sided figure. All right, so now plug in 1/2 times, in my n, again I'm plugging in for my n, 4 to the second minus 3 times 4. I plugged in this 4 everywhere I saw an n. Okay, now we get back to the beautiful order of operations. Very first thing is, let's evaluate what's inside parentheses. So I'm going to take half of 16 minus 12. Okay, then I have to finish my parentheses, 1/2 of 4. Half times 4, what's half of 4? My answer, 2. So what is the number of diagonals? 2 diagonals here. Okay, again, I'm plugging in my number first. How did I come up with that 4? Well, I stated right away, n is the number of sides. We have a 4-sided figure. I used that 4 and I plugged in, if you look at those arrows, I plugged in that 4 into each one, and that's where I came up with this equation down here, or that expression. Okay, I simplified until I got 2. All right, that's all I have for you today. I hope you enjoyed this lesson, because, well, you should, because I mean, come on, math, it's always the best. Okay, so have a wonderful day. I will see you tomorrow. Bye.